Video, we are going to see about shift registers in digital logic circuit. What is a register? Register is not a new term for us. Actually, from our school days, we are familiar with the word register. Whether it is a class attendance register where they will record our attendance in the notebook. So that is called a class register, and we have stock register where they will record the number of items available in the lab or in the library, number of books present in the library. So register is something which is used to store information. We saw registers are used to store information. If you take a computer, we have studied the parts of a computer. Always we will come across this word register. So what for they are used? They are used to store some information. But in computers, we store only zeros and ones. So how can you store zeros and ones in a computer? Using flip-flops can be used. Because flip-flop is able to store either a single zero or a 1. So you can use a group of flip-flops or many flip-flops can be used to store information. So suppose I want to store a 5-digit or 10-digit or 16-digit, I can connect a group of flip-flops to store that much information. So let us recall what is a register. It is a group of flip-flops used to store some information. Suppose if we want to store n bit of binary information, we need n flip-flops. That is, we need more flip-flops, and that type of group of n flip-flops, we call it as a n bit register. For example, you take this one. You assume each box is a flip-flop. So here n flip-flops are connected together to store some information. So normally we use a 8-bit register, 16-bit register, 32-bit, 64-bit register. So a group of flip-flops will form a register. Now we have seen that registers are group of flip-flops. Counters are also group of flip-flops. Then what is the difference between registers and counters? So counter comes under special type of register. So if you see a register, mainly it is used for data storage, manipulation or data transfer. If you see counters, it is normally preferred for counting application. Like I want to count the number of occurrence of an event, or if I want to design a clock for a microcontroller, or want to do some frequency division and I have to reduce the time period of a clock, I can go for a counter. So depending upon the function they perform, we call them as a register or a counter. So in register, we normally go for a data flip-flop, that is the D flip-flop, in which whatever input we give, we will get that the output. So D flip-flop is preferred for register. In counters or timers, toggling is more important. So normally we go for a JK flip-flop or T flip-flop. Even you can design a counter using D flip-flop also. There are different types of registers. If you take a microcontroller, accumulator plays a major role because that does all the arithmetic operation. And we have program counter, stack pointer, flag register, status register, like that. Depending upon the application, we could give them different names. Basically, all registers are same, but they do different function. So in this digital logic circuit, we are going to see only about the shift register. So how a shift register works and what are the types of shift register. So shift register is basically a synchronous circuit. You should remember what is a synchronous circuit, and it is made up of flip-flops, and we will learn what are the different types of shift register. The shift register. So register means it's a group of flip-flop. Shift register means It is a register where the data can be shifted from one place to another. Or we can say it can also be used to store the data, and after that it can transfer the data. So a shift register is basically a type of sequential logic circuit which is used for storage or transfer of data. So this is a sequential logic circuit. Sequential logic circuit means the output depends not only on the input but also on the previous output. So in such cases, you need a memory element. So for memory, we normally use a flip-flop. So a shift register is also consist of flip-flops. So these flip-flops can be used to store the data and then manipulate the data by shifting it within a register. In other words, we can say a shift register is capable of shifting the binary information from one cell to next cell. So for example, you take this picture. Here each box represents a flip-flop and it has some stored information. Okay, so I'm giving the data in this direction and taking the output in this right side. Okay, so if I give a clock pulse, this input data, whatever I give, suppose I'm giving 1, this 1 will be transferred here and this 1 will go to the next flip-flop and this 0 will be moved here and this 0 will be moved here and this 1 will come out as output. So this is the shift register. So we will learn the working of each type of shift register in the coming videos. So to implement the shift register, we can use D flip-flop, which is a data flip-flop. First thing, we give the same clock pulse for all the flip-flops. All the flip-flops will be triggered at the same instant. You give the input, and when you give a clock pulse, whatever the input available here will come to this side, or you will get the output here. So this happens with all the flip-flops. So I can shift the input data from left to right or from right to left depending upon how I design the circuit. So this circuit, the data moves from left to right. There are 4 types of shift register, namely serial in, serial out. So here in represents the input and out represents the output. Serial in means you are giving the input data serially, that is one by one you are feeding the data. Serial out means you are taking the data also serially, that is one by one you are taking the output. Next is serial in but parallel out. Parallel out means at the same time you take the output from all the flip-flops. So that is called serial in, parallel out. Then you have parallel in, serial out. That is input you will load at this input data you will load to the flip-flops at the same time. All the flip-flops will get the input data at the same time, but you take the output one by one. Next is parallel in, parallel out. So here you load the data parallelly and you take the output also parallelly. So how to remember this one? It is like remembering the series and parallel circuit. So in series means same data moves in all the circuit. Okay, and finally it comes out. Parallel circuit, you know, everywhere you will tap or it gets divided or you can tap it at every point. So that is parallel. Let us see the applications of shift register. There are various applications including the communication, that is serial to parallel communication, or in digital signal processors some registers are there which manipulate the data, or even you can do some mathematical operation with shift registers. Then LED displays where you serially send the data and you can display the data here, and this is the first in first out buffer. So these are some of the applications of shift register. So let us summarize what we have seen about shift register. So shift register is capable of shifting the binary information from one cell to next cell in a selected direction. So it is a synchronous circuit and In simple, we can say it is a group of flip-flop which is used to store the information. If you like the video, do subscribe to Read Electric Vehicle channel, and if you want a detailed explanation, you can refer to this website. Apart from this digital electronics, you can also find the material for power electronics, solid state drive, circuit theory and basic electrical engineering. Thank you.